Hello guys, Mrs. Deming. I am going to film a quick video to help you understand some things about glaciers and specifically about how glaciers make sorted and unsorted sediments. First thing I want to show you is my watermelon earth here. So this is a watermelon acting as a model of earth. I have some of our GAC that we made up on the top. This is representing glaciers and how they flow. So this would be a continental glacier formed during an ice age. During the ice age, lots of snow accumulates at the poles, and it's so cold that even during the summer that doesn't melt away, and it just accumulates and accumulates and accumulates. It gets very thick. So when I first put this out here, I had a big ball of GAC here, and it has started to flow outward. You're going to notice that some places there's little tongues, or what we call lobes, of ice in our model that are coming out further than other places, and then there's places where it's not flowing as much. So it's actually flowing because of its own weight or due to gravity outward in all directions. This is what happened on Earth. At the poles, lots and lots of snow accumulated, and then it flowed outward. That means that it would be flowing from north in the northern hemisphere to south, and if it would be doing the same thing at the south pole and flowing from the south outward. Okay, so we have evidence here in New York State, the scratches of striations, the direction of drumlins, and what direction the moraines were forming give us an idea that mostly in New York State, actually also the Finger Lakes, their direction give us an idea of what direction the ice was flowing. And ice, in most cases in New York State, would be flowing from the north towards the south. So we'd have lots of long linear features from north to south. The next thing I'm going to show you is what a glacier does, okay, when it is carrying sediments. So we get this, we've seen in the videos that a glacier picks up all sorts of sediments due to plucking. Water underneath the glacier gets into cracks, freezes, thaws, breaks pieces off. The glacier kind of absorbs those. They get welded into the bottom of the ice, frozen into the ice, and then it carries them along. That's what's it's dragging along and making striations. That makes the bottom of the glacier like a big piece of sandpaper. It is gouging out existing V-shaped valleys from rivers. So if we had an existing V-shaped valley, the glacier is going to come in and it's going to carve out all of this material and all of this material to make a nice broad U-shaped valley. So V-shaped valleys are going to turn into U-shaped valleys during this process. But all this rock material that was removed from the side of a V-shaped valley gets carried along by the glacier as the glacier is advancing. So it's going to advance when more snow is accumulating than is melting in the summer. And then eventually it's going to start retreating when the opposite is true, when more is melting away in the summer than is accumulating in the winter. So as a glacier is advancing, it's acting kind of like a bulldozer, and it comes along and it just carries all this material with it, or pushes it. So as it's advancing forward, you'll see that there are piles of rocks left along the side. And then as it retreats, it doesn't take the material with it. It deposits it. It leaves it as a deposit, and then the ice just kind of melts and moves backwards. We're going to talk in a minute what happens as it melts, what happens to all that meltwater. But first of all, there's a deposit that's made just as the glacier was carrying stuff, and then it put it down. It doesn't do anything to it. It just sets it all down in this big pile. And if you look closely at that pile, it's all mixed sizes, shapes, sediments. This is an abrasion system, so the rocks would become more rounded. That lots of them would have scratches on them or striations on them from being dragged against each other. And we formed this big long pile here. This type of sediment, of unsorted sediments, drop directly off the glacier. This type of sediment would be called till. This pile at the end, marking the end of the glacier, is called a moraine. You also have moraines marking the sides of a glacier. We have piles of sediments marking the sides of where a glacier was. So you can imagine one of these lobes coming down, kind of like a tongue of ice, and forming this shape. So the ice wouldn't be there anymore. Can one of you guys get me an ice cube, please, really quickly? The ice wouldn't be there anymore. It has left, but we'd have these nice piles of sediments left behind. Long Island, Cape Cod, those islands or peninsulas are made in this way. They're just piles of glacial stuff that was left behind. It is unsorted and unlayered. Sometimes in that, a little chunk of ice would get left there and buried by sediments. And then when it melted, if some of the water was retained there in that shape, we'd call that a kettle lake. Okay, another thing I want to show you. So these sediments are unsorted and they form a moraine. This type of sediment, if it's from a glacier, is called glacial till. Unsorted moraine. It's unsorted and it's unlayered. Okay, glaciers can form sorted sediments, but it's when they're not really acting much like a glacier. It's when they're melting. Okay, so I have a situation over here where I froze a bunch of sediments into some ice in my freezer. Okay, and now I've been just letting them sit here and melt in the warmer environment. So you can think we have some climate change, just like taking it from the freezer into my warm room. If the climate were to change from cold to warm, so now we've changed those greenhouse gas compositions, it's warming up, or some of those other characteristics of the Earth that we talked about, the tilt, the shape of the orbit, the sun output. If we change some of those other characteristics and let it warm up, now we have a retreating glacier that is melting. Out the front of the glacier when it's melting, I'm going to just model melting or maybe even a rain event. I'm going to pour some water onto the glacier and we're going to see there's lots of streams flowing underneath the glacier as it's melting. They form little S-shaped deposits called eskers. We see that out in front of a glacier, a stream actually develops. Okay, this area out in front of a glacier where water is washing out of the glacier is called an outwash plain. The deposits that are found there are called outwash. In this environment, because we now have flowing water that when it's flowing at a fast rate picks up larger sediments, and then as it slows down, deposit those sediments in order, this would form sorted sediment. So anytime you have flowing water that flows and then slows down, we get sorted sediments. All the big stuff is left up here, and then we have some of the bigger things here, and then all the smaller things get washed down into this glacial lake that we're forming here. There were several of these in our area. There was actually a glacial Lake Albany, and we see that there are very fine sediments that were deposited in the lake, and then there'd be kind of the medium stuff here in the outwash plain, and then the larger stuff gets left right up by the glacier and doesn't get reworked in this way. So sorted sediments come from running water. If there's any evidence of running water in our feature, then we're going to end up with sorted. Sometimes layered, because if we had multiple events of washing this out or rain, it'd be layered just like in the tube that I showed you in my backyard before. And then if it comes directly off the glacier, by the glacier just advancing forward and then retreating back, melting back, then we end up with an unsorted pile called a moraine that's full of a sediment called till. This could get reworked in the way here. We could have a stream come out the front into a lake, and then there would get some sorting. But this part of it would be unsorted, and the stuff out here in front would become the outwash plain and become sorted. Let's take another look at our watermelon earth and see that model of ice, our GAC, is kind of creeping ever more down the watermelon earth. This being a model of a continental ice sheet that happens during ice ages, but our previous model with the GAC in the in the straight channels that I showed you, that's what a valley glacier would look like, an alpine glacier, where there's friction along the sides and the ice flow is fastest in the middle. So we've already looked at fluid flow. The reason that the ice which is a solid, is considered a fluid in this case is all of those cracks that form in it. In the different videos that you're going to watch, you'll see that there's these different cracks that form in it. The cracks are called crevasses. and they allow the ice to kind of act in these little segments of ice that move around and flow down the valley or across the Earth's surface. You can imagine the tremendous weight. This would be a couple of miles thick on the Earth's surface, and it really compressed the Earth's surface, and we're still experiencing the Earth kind of coming out of that experience from the last glaciation, which was 20,000 years ago. The Earth is still bouncing back up from the weight of that ice. Have a good day.